Binomial distribution is example of a discrete probability distribution. Now let's say we throw a die 5 times and we have to find the number of fours obtained. Now we know that when we roll a die, we have 6 possibilities. We can get 1, 2, 3, 4, 5, or 6. And we have to find how many fours do we get on 5 throws of a die. Now the 5 throws of a die is called the number of trials that we have, or each throw is a trial. So we can say that the number of trials we have is 5. As we are trying to find how many fours we get, so getting a four is called the probability of success. We label it as P, and we know that getting a 4 has a probability 1 upon 6. And not getting a 4 will be referred to as the probability of failure. And we label it as Q. And as there are 5 possibilities in which we do not get a 4, so we can write it as 5 over 6. Now, let's say the question asked, okay, find the probability of getting 5 out of 5 fours. So let's say X is a random variable which denotes the number of fours obtained. So we have to find the probability when X is equals to 5, or the probability if we get 5 fours in a row. Now, to get 5 fours in a row, we know that the probability is 1 upon 6. So we can write it as 1 upon 6 multiplied by 1 upon 6 multiplied by 1 upon 6 5 times. And this will give us the probability of getting a 4 5 times. Now, let's say we had to find the probability of 4 out of 5 times. So let's say X is equals to 4, meaning that we obtain 4 times. Now, to find this probability, we can write it as, so let's say we get a 4 on the first 4 attempts. So we can write it as 1 upon 6 into 1 upon 6 into 1 upon 6. So this shows the probability of getting a 4. And on the 5th trial, we do not get a 4. So we can write it as the probability will be 5 upon 6. But it is also possible that we do not get a 4 on the first attempt, or the second, or the third, or the fourth, or the fifth. So let's say if I have to find the probability where we do not get a 4 on the first attempt. So it will be written as 5 over 6 into 1 over 6 into 1 over 6 into 1 over 6 into 1 over 6. This still gives us the probability of getting a 4 times. We can see that in both the cases, the probability will come out the same, but we have different possibilities. Now, when we have different possibilities for a trial, or when we are, in this case, rolling a die and we're trying to find the number of fours obtained, we use binomial distribution. Now, as there are different combinations that we can have for getting the number of fours in out of 5 attempts. So let's say we were trying to find the probability of getting 2 fours. Now this will become a bit more complex, as we can get 4 in this order. So we can get a 4, then not a 4, then a 4, then not a 4, and then again not a 4, and we can have many different possibilities. We know that each of these possibilities will have the same probability. So as we need 2 fours, so we can just simply write it as 5C2. So 5 out of 5 throws, we need 2 fours. The probability of 4 is 1 upon 6. So we can just write it as 1 upon 6 to the power 2, as 1 upon 6 will occur 2 times, and 5 upon 6 will occur 3 times. So this can give us the probability of getting a 4 2 times directly. Now we can generalize the binomial distribution as that. Let's say if you have to find probability of X is equals to X, where X can be any value, we can write it as NCX P to the power X and Q to the power N minus X, where N is the number of trials. So we can write as N as the total number of trials, P as the probability of success, and Q as the probability of failure. Now, there are certain conditions which are necessary, which should be there to use binomial distribution. So one of these is that each trial can only have two outcomes. So we can say that each trial has two outcomes. Those two outcomes are basically failure or success. So each trial has two outcomes. There are a fixed number of trials, like we had in the question. We had 5 trials. So there must be a fixed number of trials. And each trial should be independent, meaning that when we do the next trial, the probability should not be affected. So each trial is independent. And an easy example is rolling of a die, or when we toss a coin. When we roll a die, every single time the probability of getting a 4 or a 5 or a 6 remains the same. Or when we toss a coin, every single time the probability of getting a head is 1 upon 2 or 0.5. So each trial is dependent, and I can write it as that the probability of success is constant. Now, to denote a random variable x that has probability that has binomial distribution. So if we have to denote a random variable x which has binomial distribution, it is represented as x. X is a variable which is binomially distributed, and n comma p, where n is the number of trials and p is the probability of success.